All right, we're going over stats lesson 3, which is summarizing deviations from the mean. Your learning objective up here at the top, we will calculate and interpret deviations from the mean. You have one standard, which is SID A.2, use statistics appropriate to the shape of the data distribution to compare center and spread of two or more different data sets. So, if you look at these examples, it says a consumer organization is planning a study of the various brands of batteries that are available. As part of its planning, it measures lifetime, which is how long a battery can be used before it must be replaced. For each of 6 batteries of brand A and 8 batteries of brand B. Dot plots showing the battery lives for each brand are shown below. So this first dot plot is for brand A. We have 1, 2, 3, 4, 5, 6 values. For brand B, we have 1, 2, 3, 4, 5, 6, 7, 8 values. Okay, the first question asks, does one brand of battery tend to last longer, or are they roughly the same? Well, if we look at the distribution for brand A, we have this low value of 83. We have this high value of 114. So we're looking to see where the middle would be, right? Because the middle will tell us roughly how long any random battery within brand A's stash would last. So we're looking at roughly 100 to, 101, 102, somewhere around there. So if we do the same thing for brand B, we have this one that's at 73, 76, and then we have these two high ones at 117 and maybe 125, right? So if we look at the middle of that distribution, again, we're looking at roughly 100. So they're roughly the same. The battery lives are roughly the same. So the battery lives are roughly the same. Second question asks, what calculations could you do in order to compare the battery lives of the two brands? Well, what we just did was when we're looking at the middle, right, we're actually looking to see where the mean is. Remember, the mean is the average. So the mean allows us to estimate the battery life of any random battery within that brand. So the mean answers the second question. This question, do the battery lives tend to differ more from battery to battery for brand A or for brand B? Well, let's take a look at brand A, right? We have this one that's at 83, 94, 96, 106, 113, 114. So we're looking at a minimum value of 83 to 114 for brand A. So 114, but we're going to call this spread. So the spread for brand A is 114 minus the lower value, which is roughly 83. And this is going to give us a value of about 31 hours. Now, if we look at the spread for brand B, we have this low value of 73, and we have this high value of 130. So 130 minus 73 is 57. Right? Yeah, forgot the equal sign. 57 hours. So, which one has greater variability or greater spread? Sorry, brand B does. Brand B has greater spread. So this means that the battery lives tend to differ more for brand B. So brand B has more spread. So this means the lives differ more for brand B. Okay, next question. Would you prefer a battery brand that has battery lives that do not vary much from battery to battery? Why or why not? this is personal preference for me. If I was going to go out and buy something, I'd much prefer to have something that is going to last as long as it possibly can. And I know that the variability from product to product, the spread from product to product isn't going to be as great. So I would prefer brand A because it has less spread, or it doesn't vary as much as brand B. Okay, next. The table below shows the lives and hours of brand A batteries. So to calculate, this says, calculate the deviations from the mean for the remaining values and write your answers in appropriate places in the table. So the first thing we have to do is we have to calculate the mean. So we have these values of 83, 94, 96, 106, 113, and 114. So I'm going to use my handy calculator over here. I'm going to do 83 plus 94 plus 96 plus 106 plus 113 plus 114 equals 606. Then I divide this by 6 to calculate the mean. That gives me a mean of 101. So right here, I'm going to type mean equals 101. That way I have that, right? So the deviation from the mean, I want to know how far away from the mean this battery life of 83 hours is. So what I'm going to do is I'm going to do 83 minus 101. And again, if I use my calculator, so 83 minus 101, just to check my math, is negative 18. So this equals negative 18. I do the same thing, 94 minus 101. I use my handy calculator, so 94 minus 101, negative 7 equals negative 7. Same thing here, 96 minus 101, 96 minus 101, so negative 5. 106 minus 101, I could do this one mentally, equals 5. 113 minus 101 equals 12. And 114 minus 101 equals 13. All right. So we've done this. Calculate the deviations from the mean for the remaining values and write your answers in the appropriate places in the table, right? So what I want you to understand is that when we're calculating spread, we're talking about two different things. Spread is the maximum value minus the minimum value, right? That gives us how much the spread is for the entire data distribution. When we're calculating variability, right, we have to calculate how much each individual value varies from the mean. So that's what we calculated here. So if we look at our distribution, let's get the data table in there too. For brand A, we have this value, this battery that's at 83 live or 83 hours, right? That 83 hours is 18 hours below the mean. That's what the deviation from the mean means. This battery that had a life of 94 hours falls 7 hours short of the average. That's what this is telling us. This battery that has a life of 96 hours falls 5 hours short of the average. For this battery life of 106, that falls 5 hours short. The battery life of 113, that falls, that's 5 hours over. This one's 12 hours over. This one's 13 hours over. So that's what the deviations from the mean tells us. And these are the deviations for brand B. So I want you to complete exercises 5 through